Alright guys, welcome to our notes for lesson 6.1. Unit 6 is all about polynomials. Doing notes a little bit differently today. And lesson 1 is going to be about multiplying polynomials. This should be 100% review for you guys, but review is necessary and important. So basically we're going to talk about polynomials and how to multiply them. So first of all, what is a polynomial? Okay, a polynomial is basically what you get when you have a number being multiplied with a variable, and that variable has an exponent on it. Okay? And in fact, you can have many of those being added or subtracted together. Oops. Now, just so you guys know, it doesn't have to actually even have a variable with an exponent. It could just be a variable. And actually, it doesn't even really even have to have a variable at all. It really could just be a number. But basically, that's what a polynomial is. Now, there are different types of polynomials. Okay. One of those things would be what we call a monomial. A monomial is whenever there's only one term. So here's an example of that for you guys. So suppose I have 3. It's just a number, but that's what we would call a monomial. It means one number. But it could be 3x also. Or it could be 3x squared. In fact, a monomial could have more than one letter with it too. So all of these are examples of monomials. Anytime you have one term, a term can consist of a number, a variable, and an exponent all put together there. All right? But as soon as you take two monomials and you add or subtract them together, you end up with what's called a binomial or something else. So a binomial is when you have two terms being added or subtracted. So for instance, x plus 3 or x squared minus 5xy. Those are both examples of binomials. And then finally we have trinomials, which I'm sure you know. That just means there's 3 terms being added or subtracted. So the most famous one is one we've already looked at this year, the quadratic equation in standard form. That's actually a trinomial. It's a type of polynomial. But there you guys have it. Some other vocabulary for polynomials that maybe you want to be aware of. Is stuff I've already said, but I haven't written it down, so let's go ahead and write it down. This is called the coefficient. This is called a variable. Actually, I probably should just put an x there because that's usually what it's going to be. Let's use x instead of b. You have your variable. the coefficient is not a variable. The coefficient is an actual number. Okay, and then n is an exponent, which we also call a power. And you may even sometimes hear it be called a degree. Okay? So there's some vocabulary for you. And then one final little piece of vocab for you there. If a monomial has no variables, it's called a constant. So for instance, 10 is a constant because it's just a number with no variables. But if you put an x to it, next to it, now it's no longer a constant. Now it's just a monomial. But if there is no number, if there's no variable next to it, then we call that a constant monomial. All right? So there's some basic vocabulary for you guys and reminding you of what polynomials are. And that's what or Unit 6 is going to be all about. Unit 6 is all about polynomials. Today we're going to talk about multiplying them. We'll get into factoring them. We're going to talk about graphing them and all kinds of stuff. So let's go ahead and begin. So today's lesson is mainly focusing on polynomial multiplication. So I'm just going to give you guys a few different examples of polynomial multiplication here. All right, let's say I had this. So this is what we would call a situation where you would use something called distribution, which I know you guys know what that means. So basically, I'm just going to take this one term and multiply it into the parentheses. So distribution is whenever you have one number outside the parentheses, and it's going to multiply everything inside the parentheses on the other side. So now, when you multiply these things together, though, it's important to understand how to do that. You multiply the coefficients together. So for instance, 5 times 2 is 10, right? And when you multiply variables together, like x to the 5th times x to the 3rd, well, x to the 5th times x to the 3rd, you don't need to write this, but I'm just explaining something. How do we do that? Now, some of you guys already know, but I'm still going to explain it to you. X to the 5th means we have 5 x's being multiplied together, doesn't it? And then x to the 3rd means I have 3 x's being multiplied together. But we're multiplying those two things together, so now really I'm multiplying 8 x's together, which is just x to the 8th. Now obviously then the shortcut is going to be just add the exponents together. So when you multiply variables, you add the exponents. So 5 plus 3 is 8, so it's going to be x to the 8th. All right, so let's do another one here. 5x to the 5th times 9x, so 5 times 9, I'm going to multiply my coefficients, and I'm going to get 45. And then x to the 5th times x, now just so you know, that means it's x to the 1st. X to the 5th times x to the 1st means I have x to the 6th, because 5 plus 1 is 6. And then we're going to multiply it by -1, and anytime you multiply something by 1, it just stays the same anyway, so we're good to go. So there's our answer. I'm sure a lot of you guys knew that already, but just in case there was some dust on the cobwebs or whatever that we needed to dust off of your mind in that respect, we went ahead and did one of those. Let's go ahead and throw one at you guys here, just to kind of make sure that you've got it. So 3x to the 3rd power multiplied by 7x squared minus 8x plus, now I'm going to throw something in there a little weird, so just to see if you guys can get it, but 4xy. All right, so go ahead and simplify this expression. Pause the video, and when you unpause it, you'll see the solution. All right, and there it is. The only thing that was a little bit weird about the whole thing was this last one I put a y. But that doesn't really matter. The y is just going to stay exactly the same. It doesn't really do anything. But the 3 times the 4 becomes 12, and the x to the third times x to the first becomes x to the fourth. But the y just stays there. Now, if I had a y here in the front also, like let's say it was a y squared, well, now you're going to have a y squared everywhere else. And then y squared times y to the first would be y to the third. So the point here is that you can have more than one variable. It doesn't matter. But ultimately, before I changed all the answers, just so you know, this was the correct answer. All right. So let's go ahead and we'll move into the next thing here. So we know how to do distribution, but what about when you have, instead of a monomial times a polynomial, what about when you have a binomial being multiplied with a binomial? Well, I think we've done this earlier this year, but I wasn't really being real harsh about making you know how to do it. But at this point now, I'm going to say I want you guys to know how to do this by now. So let's go ahead and work it out. Now, there's a lot of ways to do this, and you're welcome to use whatever method you want to, but I use something called the box method, and that's pretty much all I'm going to stick with this year. Okay? The box method works like this. Make a 2 by 2 box. You're going to put one binomial along the top. You're going to put another binomial along the side. And if we go ahead and multiply, we can fill in the box. Like, for instance, 2x times x is going to go here. So that would be 2x squared. And 2x times negative 3 is going to go here. And that would be negative 6x. 5 times x is going to go here. And then 5 times negative 3 is going to be negative 15. Okay? And so basically, by multiplying these things together, we end up with 4 terms. Now, I'm going to write each one, I'm going to take each one of these numbers here out of the box, but I want to do it in a certain order. I always want to start with the one that has the highest power and work my way down. So I'm going to start by putting 2x squared. And then I have 2 numbers that both have just an x, so it doesn't really matter which one you put first. I'll just put minus 6x and then plus 5x. And then finally, the last one is going to be the constant. Okay, the one that doesn't have a variable. All right, so now the next thing we're going to do is combine our like terms. We do have 2 terms that are exactly the same, and very often it will be the ones that are on this diagonal here. So negative 6 plus 5 would leave me with negative 1, so it's going to be minus x and then minus 15 like that. And so there it is. So when you multiply together 2 binomials, in this case we got a trinomial. All right? And that's what we call the box method for multiplication. So you just put each term, each binomial, one on the top, one on the other side, multiply to fill in your box, then take the numbers out in descending order from highest exponent to lowest exponent, and then add your like terms together. So let me throw one of those at you guys and see how you do with it. So pause the video here. When you unpause it, you'll see the solution. All right, guys, so there you go. I'll let you pause the video here and check your work if you need to, but that's the solution. Now, I want to move on to the same question, but I want to basically show you that there's special situations that have shortcuts associated with them. So for this, I want to do a demonstration. It's not an example, it's a demonstration. And the reason I'm saying that is because an example is something that I want you guys to be able to do, and you already know how to do what I'm about ready to show you, but I want to demonstrate something for you. So let's take a look here. So let's say I have this situation here. Now, what's special about this particular situation is the fact that we have the same exact binomial twice. It's just that one of them is negative and one of them is positive. Now, I want to point something out to you, something interesting that happens here. Okay? So let's go ahead and go about it the long way. The long way will work, but there's something we can do that will make our lives a lot easier for this particular situation. And believe it or not, this particular situation is pretty common. So it's worth knowing the shortcut for. All right, so I've done my box method, and I haven't done the last step yet, but that's where the magic happens. Since these two binomials are exactly the same, you get the same number here and here, but they're opposites, so they cancel each other out when you combine. And all you're left with is the first term and the last term, which is these two numbers. So how about instead of doing the box, we have a shortcut for that instead. So anytime you have two binomials that are exactly the same, with the one exception that one is plus and the other one's minus, why don't we just go ahead and say that the final answer is going to be the first term multiplied by itself, in other words, x squared, and then the last two numbers multiplied together, a times a, which is negative a squared. So in other words, you don't need to do the box. The reason we don't need to do the box is because the middle terms cancel out. All you really need to do is multiply the two first numbers together and the last two numbers together, and you've got your answer, because the middle numbers cancel out anyway because of the fact that those two expressions are identical except they have opposite signs. All right, so let's go ahead and try to use the shortcut. So now we are going to call this an example. And let's say I gave you guys the following here. Let's say I gave you guys 2x minus 3 times 2x plus 3. All right, well, notice that they're both exactly the same. It's just that one's a minus and one's a plus. I could do this in the old school way of using the box, and I'll get the right answer, but hey, I want to save time. And so since this is one of those special situations, all I need to do is do the first number times the first number. So what's 2x times 2x? That would be 4x squared. And then we do the last number times the last number. What's negative 3 times positive 3? It's negative 9. And voila, we're done. A lot easier. Okay? So of course I want you guys to try one. Let's do student practice number 3 here. So let's say that I gave you guys 5x minus 2 times 5x plus 2. Go ahead and pause the video, and when you unpause it, you'll have your solution available to check. And there you have it. Okay? Now, there's another shortcut, another interesting I want to share with you. So I called that last one demonstration 1. Let's call this one demonstration 2. This one's not quite as convenient, but it's still worth learning. It's still worth learning. So let's say that I have not just kind of the same, but let's say they actually are exactly the same. So let's say I have x plus 6 times x plus 6. All right? Well, let's see what happens with that situation. We have x times x, which is x squared. We have 6 times 6, which is 6 squared, which is 36. And then we have x times 6, which is 6x, and x times 6 again, which is 6x. So we end up with 2 of those. And they're exactly the same this time. Instead of being opposites, they're exactly the same. And, well, that actually helps us get another shortcut. Okay? Let's take a look at it. 6 and 6 makes 12, doesn't it? So here's my final answer. But now let's try to think of a shortcut for this. Anytime you have two identical binomials being multiplied, well, you get the first term just by multiplying the first term times the first term, or multiplying it by itself, right? And you get the last term by doing the last term times the last term. 6 times 6 is 36. But where does the middle term come from? Well, it comes from putting the number that they give you, or the second term here, with the first term here, multiplying those together, and then doubling it. So what's 6 times x? Well, 6 times x is 6x, but we have 2 of them, so you double it and you get 12. So we have a shortcut, and let's go ahead and write down our shortcut here. X plus a times x plus a. All right, so here's how it works. You do x times x to get the first term. You do a times a to get the last term. But how you get the middle term? You do a times x, and then you double it. And there it is. Okay, so it's that simple. So let's go ahead and let's do a sample problem here to kind of bring that to life a little bit. So let's say, for instance, that I had 3x minus 1 times 3x plus 1. Oh, I'm sorry, I don't want them to be opposites. They actually need to be the same this time, right? So there we go. So I'm multiplying the same thing by itself. All right, well, to get the first term, we're going to have 3 terms. We already know that. The first term is going to be 3x times 3x, which is 9x squared. The last term is going to be negative 1 times negative 1, which is a positive 1. And then we do this to find the middle term. We multiply these two together. So what's negative 1 times 3x? Well, that's negative 3x, but we're going to double it. So negative 3x times 2 is actually negative 6x. And so there's our final answer. Okay? Not quite as easy as the other shortcut, but still better than the entire box method if you can grasp it. So why don't you guys give this shortcut a try? I'll give you guys one to do. How about x plus 7 times x plus 7? Pause the video here and see if you guys can get the solution. And when you unpause it, I'll show you the solution. And there you go. All right, let's do another type of problem here. So let's say that you have a binomial being multiplied by a trinomial. How do you do that? Well, that's also a box method problem, but it's going to be handled a little bit differently. Okay? And the reason why is because this one has 2 terms and this one has 3 terms. And so our box needs to be a 2 by 3. In other words, it needs to be 3 spaces long and 2 spaces deep. Now, you don't have to do it horizontally. I guess you could also make one vertically. It doesn't really matter. But what does matter is that the one with 3 terms goes in the location that has 3 spots available. And the one with 2 terms goes in the location with 2 spots available. Okay? And then we go ahead and multiply to fill in our box here. We have x cubed. We have 3x squared. X times 4 is 4x. Negative 3 times x squared is negative 3x squared. And then negative 3 times 3 is negative 9. And then negative 3 times 4 is negative 12. And then once again, we're just going to take these numbers out in descending order. So I start with the first term that has the greatest power, and then I work my way down. And then, of course, we combine our like terms. So these two are actually opposites, so they just cancel each other out. But these two can be combined. Negative 9x and 4x makes negative 5x. So here's our final answer. X cubed minus 5x minus 12. Okay. Now, just so you guys know, I'm going to call this A. Let's go ahead and move on to another example. Let's do a B. You could also have a trinomial times a trinomial. So suppose that I had x squared plus 2x minus 1 multiplied by x squared plus 3x plus 2. Okay. In that case, guess what? Your box is going to be a 3 by 3. And yes, it's tedious and irritating at this point, I understand. But hey, it happens. We're in math class, and so these kinds of things can happen. So now, since it's a 3 by 3, it doesn't really matter which one you put on the top and which one you put down the side, but basically you just put one on the top, one down the side, and once again, no surprises, you're just going to fill in your blanks. So it's going to be x to the 4th, 2x cubed, negative x squared on the top there. Then we do 3x times all three of these to fill in the next row. So it's going to be 3x cubed, 6x squared, and negative 3x. And then for the final row, we're multiplying 2 by these three numbers. So that's going to be 2x squared, 4x, and minus 2. And once again, we're going to take out all of our numbers and combine our like terms. Now at this point, if you wanted to, you could actually take them all out and put them in order and then combine. But that's a lot of numbers. And so sometimes what I'll do is I'll just combine them as I take them out. So for instance, first of all, let's start by finding the biggest power up here. The biggest power I see is x to the 4th. And there's nothing like that in there. So I'm just going to take that one out already. So we're done with that. The next thing I'm going to do is I'm going to look for any powers of 3. And I have 2 of those. I've got one here and here. So I'm just going to do some mental math and put them together now in my head. What's 3x cubed plus 2x cubed? Well, it's 5x cubed. Okay? And now we're going to move on to the squares. So look for all your squares and put those together. So I've got a 2x squared, a 6x squared, and a negative 1x squared. So 2 and 6 makes 8. And 8 take away 1 is 7. So 7x squared. And then finally we have the x's, which can be combined. 4x take away 3x is 1x. And then the minus 2 doesn't get to combine with anything. And there we go. So it's kind of nice to not have to write out all 9 of those numbers again and then combine like terms. If you can just do it as you take them out, it could save you a little bit of time. But there you have it. So that's multiplying with boxes that are bigger than 2 by 2. So let me throw a couple of these your way there. So why don't you guys try this one here? Try 2x squared plus 3x minus 1 times x plus 5. And let's see what you guys get. So go ahead and pause the video and work this one out. And when you unpause the video, you'll see the solution. All right, and there you guys go. Check out your answers, see if you guys agree. And we'll move on to our next set of polynomials. So far today, we've only been looking at multiplying of 2 factors. The factors is the word that we use to describe the 2 things that you're multiplying. But what if you're multiplying more than 2 things together? So for instance, what if you had this? Well, I've got 3 things being multiplied together. I've got 5x being multiplied by x plus 5 and x minus 5. Okay? So my suggestion to you is, well, basically what you're going to do is you're just going to multiply 2 things at a time and then just bring the third one down, and you'll eventually multiply that one in after you've done the first set. So my suggestion is when you're multiplying more than 2 factors together, look for a shortcut if you have it, and also do the box method first. So either do the box method first, or if possible, shortcuts. So now, in this case, in other words, what I'm trying to tell you to do is don't do the distribution first. You can, but I've seen students make a mistake when they do that. That 5x is something you need to distribute in, but I don't want to tell you the error yet, but there is an error that people make when they start with distribution. So My advice to you is don't even do that, okay? So let's start with either the box method or a shortcut. So you tell me, is this a shortcut method or do I have to use the box? Well, hopefully you guys recognize that was our first shortcut method. So we could just do x times x, which is x squared, and 5 times negative 5, which is negative 25. After you do that, then go ahead and do your distribution if it's there. So now I would go ahead and distribute in. To get my final answer. Okay? So do the box method first, or if possible, the shortcut. So definitely start with shortcuts first if you can, but if that doesn't work, then do a box method if you have to. But distribution should be last. Now let me tell you what the mistake is that students make with distribution when you have this situation. Students, when they distribute, well, don't write this because I definitely don't want this on your paper, but students will distribute it like this, but then they'll also distribute it to the other one. You do not do that. If you distribute it into both pairs of parentheses, you're actually multiplying the 5x twice. So if you don't start with distribution at all, then you end up just doing it once like you're supposed to. So that's why I suggest shortcuts first, followed by box, followed by distribution. Okay, so let's take a look at another one here really quick. I'm going to do another example. Number 2. Check this out. Okay. So this is a really ugly problem, but luckily we have some shortcuts to help us out a little bit here. So first of all, I want you guys notice the something up here that's a little bit weird, don't you? This guy. But you guys know what a square means, don't you? I mean, that just means that you're multiplying something by itself. So I'm going to rewrite it. So instead of putting x plus 4 squared, I'm just going to put x plus 4 times x plus 4. Now, if you want to write this down, you can, but here's a common mistake students make with this situation. If you have a 2 here, a lot of students will just say, oh, okay, well, that's x squared and a squared. So it's going to be x squared plus a squared. And that's not true. That is not true at all. The correct understanding of that is that it's x plus a times x plus a. And as you guys know, that turns out looking quite a bit different. Okay, so obviously these two expressions are not the same thing. So you do not distribute an exponent over addition like that. Okay, so that's a common mistake that students make. This is how you want to do it. So my suggestion is if you guys ever see a binomial being squared, I would just rewrite it as 2 binomials that are being multiplied. Okay? All right, so back to this. That's what I did. I just rewrote it. Now, as I said, look for your shortcuts first. I see a shortcut here. This is our first shortcut that we talked about, where they're the same but opposite signs. So for that shortcut, we do first times first, and last times last, and we're done. I see another shortcut here. We can do first times first, last times last, and then these two multiplied together but doubled. Okay. Now what do we do? So we did our shortcuts. Now what do we do? Well, after that, we do the box method if we can, because I still don't have just one distribution problem here right now, right? I've got this, and I don't want to do distribution until the very end, until it's just 6x times one thing, and I still have 2 things here. So I need to get those two things multiplied together. Now how do you do it? You're going to do the box method. Now this time though, our box is going to look a little bit different because it's a trinomial being multiplied with a binomial, right? So let's go ahead and take a look at that. Actually, I'm going to leave that 6x off for a second, and I'm just going to do the box method. So since this one has 3 terms, it's going to be a 3 by 2 box. I've got 3 terms and 2 terms, so it's going to be 3 by 2. So that would look like this. And now we're going to go ahead and multiply to fill in our box. So x squared times x squared is going to be x to the 4th. X squared times 8x is going to be 8x to the 3rd. X squared times 16 is going to be 16x squared. Negative 1 times x squared is going to be negative x squared. Negative 1 times 8x is going to be negative 8x. Negative 1 times 16 is going to be negative 16. And then what we want to do now is we want to take out all of our numbers and put them in order. So we have x to the 4th is first. We have 8x cubed is next. Cross them off as I go. And then we have 2 terms that have an x squared. So that would be 16x squared and negative x squared. I have 1 term with an 8x and a constant. And now I'm just going to put together the terms that are the same. So for instance, these are both x squareds, so I'll put those together. And that's going to be 15x squared. Now remember, that's just for this pair. This 6x here still needs to come all the way down there. So we did our shortcuts. We did our box. What's the last step? The last step is to do the distribution. So let's do the distribution. So we're going to distribute there, and we get 6x to the 5th. We're going to distribute here, and we're going to get 48x to the 4th, and so on. 6 times 15, I believe that's 90. And then I get x to the 3rd. Uh, 60 and 36 is 96. So I think it's negative 96x. And there's our final answer. So distribution comes last. Okay, so there's our full problem there. That's about as ugly as I can make it. Shortcuts first. Box method next, distribution last. Okay. So let me throw some problems at you guys to get you to practice this multi-tiered multiplication stuff. Let's see. Student practice. Okay, so go ahead and try this problem. Pause the video, and when you unpause it, you will see the solution. Okay, so here's our solution there. Step 1 is I rewrote the x minus 3 squared as x minus 3 times x minus 3. The next thing that we did there was I did the shortcut, because what I've put in a box here is a shortcut. And that becomes x squared minus 6x plus 9. And then for this part here, I went ahead and did the box method, and I ended up with that. And I've shown my work for the box method over here if you want to check it. And then finally, I did my distribution. Okay, so remember, shortcut first, then the box method, then distribution. Probably the safest way to go. And I'll show you guys one more example, but for this one, we don't really, I'm not going to give you a student practice for it because honestly, it's just kind of not necessary. Where'd we leave off? We were on example 5, right? All right, so once I show it to you, though, I think you guys will be pretty cool. You'll get it. It won't be any trouble for you. So, last example here, example 6. You may see problems that look like this. Okay. Now, in that case, once again, you can't do this. That's a no-no. Okay. You have to understand that that means x plus 1 times x plus 1 times x plus 1 is what that means. Okay. So you have to write it out 3 times. So in that case, from there, you would use a shortcut, which I can. For these two, I can apply the shortcut. Now, you could also apply it for these two. It doesn't matter because they're the same, right? But either way, you're fine. So go ahead and just apply the shortcut to any pair you got. And so I've got x squared plus 2x plus 1 if I do my shortcut correctly. And then from there, you're just going to do the box method. And I'm not going to show my work for the box method this time. I'm just going to put the answer up there. But I just wanted to kind of go over that with you guys a little bit. So if you ever see a cube, remember, it's the same thing as with squares. You can't do that. That's a no-no. You have to write it out 3 times. And then after that, just apply your shortcut and do the box method. Okay? And that does it for our lesson for today. So until next time, I bid you good day.